in the database environment. And let's use sudo docker ps to actually list out that all the processes that are running right now. And there we are. We actually see all of the images that are running. We have the names, the commands, the images, and everything's up and running. And if we want to close both of those images, we can actually use a single line of command as well. And that command will be sudo docker-compose down. And that closes both of the images. And we can see that all the databases and the web services images have been closed, and sudo docker ps will actually list that there is nothing running. And that's how to use Docker Compose.
Why exactly the Docker networking is it important? Let's talk about some scenario over here. So my application is something which totally works perfectly fine into my system, and there is no issues on there. I ran it perfectly fine and I got the response. I'm able to interact, everything I'm able to do. But the same application does not work on the other person's system. Now what could be the issue? Because it's working on one machine and it's not working on another machine. Now the application does not work on another system because there is a difference in the computer systems. Maybe one system is having a different machine and another system is having a different machine, and you may be having some of the differences, maybe in the term of hardware, maybe in the terms of software. So the differences are possible in two different machines. So how we can get a solution that we don't get this kind of problems, and once the container is prepared, it should be able to run it across different systems. So Docker networking is the ideal solution for this problem over here. With Docker networking, the application works totally fine, and it's something which can work on any system. You don't have any dependency that it will run only on a specific machine or a particular system. So what exactly is in Docker networking all about? So Docker networking enables a user to link a Docker container to as many as networks he or she requires. So you can actually connect a Docker container to a specific network. The Docker networks are used to provide complete isolation to the Docker containers. So you can have it like, okay, I want to run some couple of containers in a different network, and another containers I want to run it into a different networks. So you can do that isolations, and the whole purpose of doing that isolation is so that we will be able to have a proper networking and proper executions and all that stuff. So Docker networking is a very important concept when we talk about, or when we come up with the interaction or having the Docker containers isolated. So it resolves most of the problems. Okay, so you can have like multiple containers in running in same network. You can have different particular networks also there. So a specific network have its own attributes, and then you can use those attributes to connect to that containers and to access that containers. But the whole idea is that the containers are something which is specifically running in a set of servers or in a set of platform. So whenever I'm trying to look forward to that particular container, it has to be there into a network. If you don't run it into your custom network, then whatever the default network present, it will be hosted in that network there. So how does the Docker networking actually works? So you got a Docker file. So using the Docker file, you got a custom Docker image, and from this Docker image you have to actually go there and put up like the Docker container. So you can also store this Docker image to the Docker Hub, so that the same Docker image can be shared across different users, and they can also pull down their Docker image and they can have the container running in their systems. So for the collaborating the Docker image, you require the Docker Hub, and the container is the ultimate thing or object which we need to create out of the Docker image. When we go with the particular process, when the whole process goes on over there, so what happens that instead of the Docker Hub, you can use your own private repositories also. That's something which totally relies onto you, that how exactly those things works on. So a Docker file creates a Docker image using the build command. A Docker image contains all the project source code, all the dependencies. Using this Docker image, you can actually run the source code in order to get a Docker container. The moment you initialize or run an instance of Docker image, you will be able to get a Docker container. You can actually use the Docker Hub for collaborating or for sharing the Docker image. So you can store the Docker image on Docker Hub, and then different people can actually go ahead and download or pull this Docker image onto their system, and they can also run their specific containers. So what are the different advantages we get with the Docker networking? Very first one is the rapid deployment, portability, better efficiency, faster configuration, scalability, and the security over here. So these are some of the advantages which we get when we talk about the Docker networking here. Now let's talk about the container network model here. So what is the network model we are looking forward from the containers perspective? Now this is a kind of a architecture here. Now in this one, let's see that how it actually works on. Now you have a Docker engine, which is a main component which takes up all the things, and all the important components are actually integrated with each other. Now the network sandbox is the one in which you will be having your container running up and running. Now every network is having its own attributes, the particular different gateway IPs, the IP addresses, the range of IP address, the CIDR blocks, also everything can be different for two different networks. So the whole point is that you will be defining, okay, if you don't define that I want to run this particular container into a specific network, then definitely that's going to run into default network which gets created the moment you do the installation of Docker. But anyhow, any network is required for running a Docker container. So there are different network drivers which is available there. So if you feel that you want to create a network, so you have to choose a particular networking or the connectivity over there, and it really helps us to understand that how the configurations and how the different modifications and those changes can be really done here. So a lot of changes are actually going on and performing there, and this really helps us to understand that how the things are being done as such over there. So network is something which is very important from the containers perspective. So the network sandbox is a kind of a isolated sandbox that holds all the network configurations of the containers. So you will be requiring at least one Docker container network if you want to run a container in that particular sandbox. So sandbox is created when a user requests to generate an endpoint on the network. So that's where the sandbox gets created. It can have several endpoints in a network as it represents a container's network configurations like IP address, MAC address, DNS name. So every container will be having its own unique IP address, right? So that can be a particular endpoint to connect to that container, and it can have it like different endpoints and different networks. So that's always the possibilities which is available there. Now the endpoints establishes the connectivity for the container services with other services also. So the moment you work on the particular endpoints, so that can be used for having, okay, there is a service running in a container, so how you can do that. So in order to connect that, you require these endpoints so that you can establish the connectivity with the container services, whatever running inside these Docker containers. Right now, the network is something which provides the specific underlining network attributes like the networking support to the Docker containers, because these network sandbox boxes will definitely have a requirement of the network. So how you're going to get that you will be only able to get when you go, okay, I will be looking forward for the connectivity and I can go for the communications and I can give the hardware, because although it's a OS level virtualization, but still you require some interaction with the hardware from the networking perspective. And then Docker engine is the base engine which is installed on the host machine, and it's actually the main component which makes sure that the Docker containers and the corresponding Docker services are always up and running. And the using the network drivers, you can actually create multiple networks onto your system, and you can have those configurations. Now the network architecture is something which helps us to provide the connectivity among the endpoints that probably belongs to the same network, and it's something which is a kind of isolated network. So different networks can be isolated networks, and we can have the endpoints to them. So there are different ways in which we can establish the connectivity, and this is a complete network architecture which is there. So you have a network drivers, you have the networks, you have the network sandboxes in which internally the Docker containers are running, and then these network sandboxes are having their respective endpoints there to access them to establish the connectivity. Now let's talk about the network drivers. Now there are 5 type of network drivers which is available. First one is the bridge, host, none, overlay, and MAC VLAN. So these are the different particular network drivers which is available over here. First one is a bridge. It's a private default network created on the host. If you go there, if you go to the installation of a Docker, this is the default driver which gets installed onto the system, onto the host. The containers linked to this network will have an internal IP address through which they can actually communicate with each other. On the same machine also, you can establish the connectivity. You can connect to the containers using that private IP address, but outside the server, you will not be able to have the communication. But internally you can connect to the containers, and containers can also interact with each other. They can also communicate with each other with this one. The Docker daemon creates the Docker 0. So if you run the IP config or if config on the system, you will be able to see a Docker 0 kind of a Ethernet bridge network which is created, using which you can see that, okay, this is the network which is created by default. It's a default installation or default configuration which automatically happens the moment you set up a Docker instance. So you don't have to go into the configurations or in the setup of there. It will be already available on that particular installation mode there. And the next one is the host one. So it's a public network. So when we go with the public network, it's actually uses the host IP address and a TCP port in order to interact with the service running inside the Docker container. So if you are looking forward that I want to reach out or I want to connect to the container, but I want to use an IP address which can be accessible from outside world, probably some other server should be able to resolve that. In that situation, the host network driver comes into the picture. So it effectively disables the network isolation between the Docker host and the Docker containers, which means that using this driver, a user can actually run multiple containers. It's not possible for the user to run multiple containers on the same host because of the fact that you are using the host IP address. Now, when we were talking about the bridge connection, at that moment of time, we were getting the private IP addresses, which was totally isolated and totally unique. So there were actually, if you create using the bridge connection multiple containers, so you will see that if there are 5.3 containers, everyone will be having a different private IP address. But the moment you go for the host one, so in that situation, the IP address is not going to change. So you get some restrictions, okay, because the combination is of IP address and port. So IP address and 8080 can happen only once. It cannot happen multiple times. So that's a limitation, that you cannot run multiple containers on the same host due to this restriction. And next one is the none. So in this network driver, the Docker containers will neither have any access to the external network, or it will not be able to communicate with the other containers also. Total isolation and total private containers are being done when we use this driver. So these options are usually used when you want to disable. So this is not doing nothing but disabling the total networking functionality for a specific container. That's what is happening over here. Next one is the overlay. So this one is utilized for creating an internal private network to the Docker nodes in the Docker Swarm cluster. So overlay does not comes up in case of a standalone Docker installation. The moment you go with the particular Docker Swarm cluster, at that moment of time, the overlay type of network is created. So Docker Swarm is an orchestration tool, so that requires a overlay kind of driver which can help them to achieve the networking in case of cluster, because in case of Docker Swarm you have a master node, manager node, worker nodes, different machines are there. So in that situation, overlay is the main component, or is the main type of driver which is used. And then we have the MAC VLAN. So it simplifies the communication processes between the containers. This network assigns a MAC address to the Docker containers. With this MAC address, the Docker servers will route the network traffic to a router. So it's not on the basis of IP address, it's actually on the basis of MAC address. So on the specific MAC address, the Docker server will redirect the network to a specific router. Right, it's usable when a user wants to directly connect the containers to the physical network rather than the Docker host. So that's where this communication works on. So it's a direct connectivity between the host network and the Docker container. So there is no virtualization which is happening over here. So it's something which is giving a direct access to the networks, but it's definitely on the basis of MAC address on which the communication is happening. Now let's talk about the networking implementation, and we'll see that how we can go for a particular bridge network implementation there. So let's go back to the virtual machine. So I am connected to a particular system here, so I can check that if the Docker is available to me, and I can just run the Docker version. So it says that okay, the client and the server component both is available there. Now we are going to see that what are the different containers which is what are the different Docker containers network which is available there. So I'm going to run a command called docker network ls. Now the moment you do it, over here you will see that none, host and bridge, these are the different containers network which is available there. And you can see their network IDs, the names, the drivers. The drivers is also very important because that's what we are going to use here. So it's a very good one here. So the default one, you can see that the bridge is available, and it's a default one whenever you create any container. By default, whether you give the container attribute or not, it's something which gets created into the terms or in the basis of the container only, in the default network only. So how we can get that? We can always get that part by having the understanding that what network we are using. So I'm going to run a couple of containers or small container, and we can see that how exactly the containers can be executed and can be done over there. Right, so let's see. So I'm going to run a command, docker run -d it -name alpine1 alpine image is what I am going to use, and sh. So it pulls down the alpine image. That's what it happened, and the same thing I'm going to run, but this time I'm going to run alpine2 because I want to create two containers. Right, so with this one, what will happen, that I will be having two containers available here. So I can say like docker ps. So I can see that two containers are running, one is the alpine and one is the alpine2. Right, so now what happens, that we will see that how the connectivity happens and what are the network details. So what I'm going to do is that first of all I'm going to do an inspect over there onto the bridge connectivity so that I can get the detailed information. So this is the name of the particular ones of the network. So this is the network which is available, and this is the default one. So if I scroll up, you can see that this is the name of the bridge connectivity, and even if you run the docker network ls, so you will be able to see that the ID also. So ID also, if you compare, so E65, that's the one which is available. Now this one is something which is using a driver called bridge, and here you can see the subnet information. Now if you scroll down, you can see that two containers are available here. So I did not provide any kind of network details, but definitely what happens that the two containers which I deployed are basically running inside this network. Okay, and you can see that the bridge name docker 0 is the internet network which gets created, which during the installation of docker gets configured. Now you can see that this is the IP address, this is the IP address here, this is the MAC address, and this is also a MAC address here. So the IP address, you can see this is a 3.0.3 in the last, and this is .2 over here. So you can see that the increase, the sequence is there. So alpine 1 was having an IP .172.17.0.2, and alpine 2 is having an incremented IP address like a different one as in 3. So you can see that these different IP addresses are there, and represents, if you want to access them, if you want to connect on them, you will be able to have the connectivity accordingly. So even if you go inside these containers, you can actually see that what exactly the connectivity you want to establish or the connectivity you want to perform here. Right, so this is the way that how the network usually works, and the networks bridge you are using over here is the bridge ones, which definitely helps us to understand that how the configurations can be done. Now, so what we are going to do over here is that we will try to see that how exactly we can go ahead and we can connect on there, and we can also see that if we are able to communicate with each other, because probably if I run like ping command over here, and I'll put the containers like 2 and I'm able to reach out. There is no problem in reaching out to these IPs because these are the private IP addresses, and I will be able to reach out to them without any problem and without any concerns. So from the current connectivity perspective, there is no problem as such, and I have a connection available over here. But let's see, we'll go back to the containers. We'll see that how exactly we can we can reach out the one container with each other. So I want to connect Alpine 1 with Alpine 2. So how we can do that? So I'm going to use like Docker Alpine 1. Okay, now I got a terminal. So what I can do is that I can go for the IP address show. So with this one, what will happen that I will be able to know the IP address. So .2 is the one which is available over here. Okay, so this is the IP address. Now I can simply do the small ping command. So I can say like ping google.com. so that will show me that if I have an internet connectivity, so that is great. So I got a connectivity with the internet over there, so I will be able to reach out any websites or any kind of that order. Now I have another IP. So .3 is, remember we were using the different IP, so I can actually do a ping also here. So ping -c5 request will put, and 3 will do here. Now we are trying to reach out to the Alpine 2 over there. So although we are connecting to the Alpine 1, but we have the connectivity with Alpine 2 also. So from Alpine 1, you can connect to the Alpine 2 containers. So that shows that since both of them are running in the same container, so they are having the automated connectivity, and you can easily reach out to them, and without any issues you can do that. And similarly, the same thing you can do it in case of Alpine 2 also. So you get it connected to the Alpine 2, and you can just follow the same thing. So you can connect it with the, if you go to the Alpine 2, you can connect to the Alpine 1 also. So if you come out, the containers will be always up and running, and you will be able to have the mechanisms there. So the whole idea about these things is that it will be basically helping you to understand that how the executions can be done and how we can perform the activities as such over here. So this is the way that how we deal with the networkings and how the containers gets created into a network, and then they can interact with each other, right? So this was the demo on which we talk about that how we can talk about a bridge network implementation with the Docker containers.
Did you know the famous global researcher Gartner predicts by 2023 more than 50% of the companies will be adopting Docker containers? However, a serverless container like Docker will have a rise in the revenue from a small base of 465.8 million in the year 2020 to 944 million in the year 2024. In this video, we will be doing a side-by-side comparison of the Docker containers and the virtual machines. What exactly is a virtual machine? It is an isolated computing environment that enables a person to use an operating system via a physical machine. Virtual machines provide the functionality of a physical computer. As you can see on my screen, there is a virtual machine, and this is how a typical virtual machine looks like. Now, let's look at what a Docker is. Docker is an operating system level virtualization software platform that enables software developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. And a Docker container is a lightweight software package that includes all the dependencies like frameworks, libraries, and many more, which are essentially required to execute an application. This is the architecture of Docker tool. Now let's move on to our next main topic for the discussion, that is Docker versus virtual machine. When it comes to comparing the two, we could say the Docker containers have much more potential than virtual machines. As you can see on the left and right hand side, both the images look similar. Now let's define the layers of virtual machine from the bottom up. Let's begin with the infrastructure. Infrastructure could be a computer system, a laptop, or a virtual private server such as an Amazon EC2 instance, or Azure Virtual Machine, or GCP Virtual Machine instance. On the top of the infrastructure runs the operating system. An operating system is a software that manages hardware and software resources for the computer programs. On your laptop, this will be likely Windows, Mac OS, or Linux flavored operating systems such as Ubuntu. Next comes the hypervisor. A hypervisor is a firmware that builds and runs virtual machines. There are two types of hypervisors. Type 1 hypervisors are HyperKit for Mac OS, Hyper-V for Windows, and KVM for Linux operating systems. And Type 2 hypervisors are VirtualBox and VMware. Then we have the guest operating systems. Consider an example where you want to run two apps on your server in total isolation. This process would require two guest operating systems which will be controlled by a hypervisor. Virtual machines come with many dependencies, where each guest operating system will at least occupy 512 MB of your RAM. This is worse because each guest operating system needs its own CPU and memory resources. Eventually, this will be expensive. Then, on top of that, each guest operating system requires its own dependencies such as binaries and libraries. Since every application has different dependencies, it requires its own set of libraries. Finally, it's the application. This layer consists of the source code for the application you have built. This was all about the virtual machine on a server. Here's what the same setup looks like when you're using Docker containers. Here, you'll notice that there are a lot fewer layers. Docker doesn't require a bunch of massive guest operating systems. Let me break it down from the bottom up again. Infrastructure and host operating systems are the same as we discussed for the virtual machine. Coming into the third layer, instead of a hypervisor, Docker uses Docker Engine. Docker Engine or Docker is a client-server application that builds and executes containers using Docker components. Next, we have our dependencies. Just like on the virtual machines, here dependencies are built into a template called Docker images. As you can see on the screen, each application is still isolated and occupies less space. Now, let's have a look at the significant differences between Docker and virtual machine. Let's start with the operating system first. Docker is a container-based model where containers are software packages used for executing an application on any operating system. On the other side, virtual machine is a container-based model. It utilizes user space along with the kernel space of the operating system. A kernel space is where the core of the operating system runs and provides its services to the user. A user cannot modify this space, and user space is the portion of the system memory in which the user's processes run. Docker containers share operating system kernels with other applications and result in a higher server efficiency. Hence, Docker provides the most substantial default isolation capabilities among the other configuration tools. On the other hand, virtual machines do not share the operating system. Also, it does not provide isolation in the host kernel. In Docker, multiple workloads can run on a single operating system. But in virtual machine, each workload needs a complete operating system or a hypervisor. The next significant difference between the two is the performance. In the case of Docker, they use the same operating system without any additional software like hypervisor. In case of virtual machines, performance issues are a major problem. It can be due to the several reasons like CPU constraints, memory allocation, network latency, and many more. Running multiple virtual machines lead to an unstable performance. Docker containers can start up quickly and result in less boot-up time, whereas virtual machines do not start quickly and lead to a poor performance. Now, let's talk about the next difference, which is portability. With Docker containers, a developer can build an application and store it into a Docker image. Later, he or she can run it across any host environment. But when it comes to virtual machines, it has portability issues. Virtual machines do not have a central hub like Docker does, and it requires more memory space to store data. Docker containers are smaller than virtual machines, due to which the process of transferring files on the host file system is easier. On the other hand, dependency on the host operating system and hardware makes virtual machines less portable. While transferring files, virtual machines should have a copy of the operating system and its dependencies, due to which image size is increased and becomes a tedious process to share data. The boot up time between the both is very different. The application in Docker containers start without any delay since the operating system is already up and running. On the other hand, virtual machines take much longer time than it takes for a container to run applications. These containers were basically designed to save time in the deployment process of an application, whereas in virtual machines, to deploy a single application, virtual machine needs to start an entire operating system, which would result in a full boot process. So those were the major differences between Docker and a virtual machine. Now let's discuss the minor differences between them. Docker is not always in a running state. It stops when the stop command is executed, whereas the virtual machines are always running in the background, which will result in huge RAM consumption. Talking about snapshots. Docker has a lot of snapshots. A snapshot is an image that you can upload on a private repository to access it on another host. But virtual machines do not consist of any snapshots. In Docker, images can be version controlled just like Git. They have local registry called Docker Hub where users store and distribute container images. On the other hand, virtual machine does not have a central hub. They are not version controlled. Docker can run multiple containers on a system. Users can connect multiple containers using user-defined networks and shared volumes. Multiple containers can be accessed on the same machine and share the operating system kernel with other containers. Each container is isolated in user space. Also, Docker containers occupy less space than virtual machines and start instantly. Virtual machine can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Multiple containers can be started at a time on the Docker engine. The isolation environment allows a user to run and deploy several containers simultaneously on a given host. Virtual machines can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Now that I have told you the differences between Docker containers and virtual machines, let me show you a real-life case study of how BCC uses Docker. BCC News is a British news channel over 500 developers working across the globe. BCC News delivers broadcasts in almost 30 different languages and with over 80,000 daily news in English alone. The news channel ran more than 26,000 jobs with more than 10 continuous integrations with sequential scheduling. The company had issues with identifying a way to unify the coding process and monitor the continuous integration consistently. Also, the existing jobs took up to more time, that is, up to 60 minutes to schedule and perform its task. Docker allowed BCC News to eliminate job wait times and run jobs in parallel. It also gave the users the ability to work in a more flexible CI environment where entire code processes were unified and stored in a single place. However, Docker succeeded in spreading up the whole continuous integration process.
In this topic, we are going to talk about what exactly is the various Docker commands which we can use to interact with the Docker images, Docker containers, and some core components of Docker is what we are going to talk about in this particular topic here. Now let's begin with what exactly is in Docker, because we are trying to explore that what are the different Docker commands we can eventually run to interact with the Docker, because you have the command line interface which is available there, using which you can run some couple of Docker commands, and internally you will be able to have some particular processing which is done at the Docker end. Now Docker is a configuration management tool. It's being used as a configuration management tool just like the other configuration management tools in the industry, in the market. Now it's pretty much used by the developers to make sure that they wrap or they package an application with all its dependency. Now normally in a virtual machine, what we do is that we host or we install the dependencies separately, and then on top of that we host our web applications or whatever the application we have, we host it on that particular framework or platform. But here in this scenario, we are talking about like how we can wrap an application all together with its dependencies. All the dependencies are getting wrapped, are getting packaged up into a single entity, and that's what we call it as a Docker container. So Docker is a configuration management tool and a containerization tool which is there, which helps us to wrap or package both the dependencies and the source code within a single unit called Docker container. And this is the Docker container which the developers use to do the deployment across multiple environments. So as part of the process, when you are working on the hosting of your application onto your Docker, so ultimately you are looking forward for an entity called Docker container. So if you go through the diagram over here, so in this one, this is in kind of a basic way architecture that how the Docker is being architect and is getting deployed. So initially you have an infrastructure, like a physical infrastructure is there. You have the particular cores, memory, infrastructure, all those things are available there. Now on top of this infrastructure, you are hosting up a host operating system. This host operating system is responsible for taking up all the requests and interacting, providing a particular interface between the particular Docker and the infrastructure, the core hardware. So it acts like a medium over here. So after the host on operating system, on top of that you are going to install the Docker engine, Docker software. It's just like you got a virtual machine on Linux, and on top of that you are installing the Docker software. Once the Docker engine is installed, then Docker engine will take care of management of the Docker containers. You don't really have to do a lot of work. Docker engine is going to take all the internal work, the communication between the operating system and the infrastructure, so that needs to be done by the Docker engine. So Docker engine makes sure that the different container gets up and running, and you can see that in this scenario, in this diagram, we have container 1, container 2 and container 3, and all these containers are actually having its own applications and the dependencies binded up together. So that's the reason why we are saying that with the Docker we are getting a complete package. End-to-end package is being given to us, in which we have both the particular source code and the binaries and the executables embedded inside that. So it's a complete package which is getting created in the form of Docker container, and the developer is responsible for preparing this Docker container so that these containers can be deployed on the Docker host and you can get your application up and running. So this is what we have Docker into a particular and the architecture of the Docker here. Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own, right? So in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a Docker, a kind of a Docker build script. Just like in case of Maven, we have .xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you're trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up. The custom Docker images are built up with the help of Docker file. So Docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now, how to list down all the Docker images? So Docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete a docker image, so you can go for docker image rm command to remove a docker image completely from the docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how Docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the run attribute, where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of simply learn, or whatever the name you want to give. You can give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that what for what purpose you are preparing this image. And with that, what will happen that it will take up the values, whatever attributes you have put up into the Docker file. So that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like docker image rm and simply learn. So if you do that, what will happen that your Docker image which is related to simply learn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called docker image and then rm command to remove the Docker image from your system, from your host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container, and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command. But the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as in particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container you can rename it with a new container, and that's how the particular rename of an existing container will be done with onto the docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we're going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have an instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's an heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps-a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a Docker container here, and the created status also shows that yes, the Docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run Jenkins, and what it will do, it will definitely help you to get the container created onto of the Jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself, that whole Jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a Control-C over here, because it says that Jenkins is up and running. So you can start using this one according to your requirement over here, right? So I'm just doing Control-C so that it can be stopped over there, right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available, but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_Jenkins. So that you can easily do with the help of docker rename command, because that will rename the Docker container name so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now, if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container, but we do not remove it from the Docker host because we are not going for the cleanup. Now, cleanup is very required because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup purge of all the containers which is running on the host machine here, and that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this really completely removes all the stopped containers onto the Docker host over here in this scenario. Now, second one is that it creates a new image from a containers file changes. Now, the way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now, if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such.
What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do here is that in order to see that how we can actually remove all the stop containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where for example we have got some stopped containers, but again you have to manually remove them one by one. Now if you don't want to do that stuff, if you feel that whatever the stopped containers which is available, that should be automatically removed from your system, then we have a command called docker container prune. Now for this, what we really need to do is that we need to actually stop this container, because again it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prune command over here in this one. And then I can run like docker container prune command, which will basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular Docker image. Let's say that we got a Docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a Docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a Docker image. So all you can do is that, let's say, let again run a particular container of HTTPD here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes. Now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit. That's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be, yes, again copying that particular container ID, and we'll say like custom image colon version 1. So we will be giving a custom name or a name of a Docker image and a tag over here in this one. So this will basically save my Docker container which is available in this one in the format of a particular Docker image, in a format of a Docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this, whatever the changes you want to do, you can do that, and you can then put it up into the form of a Docker image, a final Docker image. And at last, if you want to remove it, so docker rm and container ID. Now this again docker rm will come remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So docker ps -a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content. Right, so these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new Docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system. Right, so once the container is restart, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one. Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will be list down on all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it, now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that docker container ls is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content. And then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container, and it will go in the wait status. So docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you because the container is in stop status. So again you have to do the restart of the container to make sure that the container is up and running. Right, so the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again I had to restart that container over here in this one. Then again of course we have like docker wait, then container is there. So this will basically put the container into a block status, because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output. And lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0. But in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how way you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. all you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest. So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull a MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub, and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case, it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same if you run Docker push custom image version 1. So if you do that, it will not be pushed into these particular Docker Hub. So it's going to throw error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image, the same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like Docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does require the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations. But let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d httpd, like I'm just running a dummy container over here, so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you, so you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available, because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all, everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that, okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now, in order to log into the Docker Hub, because before doing the Docker push, you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the Docker login command where you can see that how the execution can be done. Now, using the Docker login command, you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that, okay, the configurations is done, and we can go ahead and we can perform the execution. So Docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again, if you try to run Docker login, you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one. So the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the Docker volume create command. So Docker volume create command is there, using which you can create the Docker volumes, and you can pretty much do that setup. So Docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out that what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the docker swarm commands here. Now docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So Docker Swarm is there where we can see that how the execution needs to be done. So you can go for the command called Docker Swarm init command. This will actually go for an initialization of our Docker Swarm cluster, and once the Docker Swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that and you can execute as such over there. So Docker Swarm init is the command using which you can actually see that how the execution needs to be done and how we can perform the mechanism and the changes over here. So Docker Swarm init hyphen advice ADR address is there, which helps you to see that how the executions can be done. Now joins, you have the Docker Swarm join command which is available there. Now if you go for Docker Swarm join command, so you can have a particular host. So Docker Swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the Docker Swarm cluster. And then if you want to leave from the Swarm cluster, then you can go for Docker Swarm leave command and it will be simply removed from the Docker Swarm cluster there. Some of the couple of commands using which we can initialize or we can remove from the Docker Swarm cluster here. So Docker Swarm is already being initialized or is being created when the moment you do the installation of Docker. So Docker Swarm init is the command using which you can initialize a Docker container. Now once you initialize over here, so after the initialization you got a command which you want to add it, like you want to run it onto the Docker Swarm cluster. It will act like a worker node so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like Docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your Docker Swarm cluster, so all you can do is that you can say like Docker Swarm leave -f, and you will be left out of the Docker Swarm. And now if you want to run like Docker node ls, you will not be able to get that output because it's saying that there is no particular Swarm manager which is available. So you can run Docker Swarm init or you can run the join command to connect to that specific node, but we have already left it and nothing is available over here. So that's a way that how you can manage like what are the different Docker Swarm commands we can typically run to manage the Docker Swarm cluster. Now let's talk about the Docker Compose commands. Now Docker Compose commands is actually there using which we can create multiple containers. It's not only one container which we can create, go for multiple creations of the containers with the help of Docker Compose file. So Docker Compose -version is the command which we can give you the version of Docker Compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file we can create or we can have that particular Docker Compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification so that you will be able to have the modifications done and you will be able to find out a particular multiple containers gets created all together. So Docker Compose is the way that how you can do the setup. How you are going to run the Docker Compose file? So in that case you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker Compose one. So let's try to run some commands related to Docker Compose. So docker-compose version will let you know that what exactly version of Docker Compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker Compose file. So what we need to do is that we need to create a docker-compose.yaml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing, because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080, so, or sorry, 80 is what you can dash for the Nginx, because it runs on 80 port. But now I have to run like 80 port, I want to dash that port over here in this one, so I can specify that 80 port should be available in this one. So I'm going to save this one here, and I'm going to run a command called docker -compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode, and it will be executed. So it will process your docker compose file, and since you have used a standard name called docker-compose.yml, so it will automatically pick that docker details and start creating the container.
Kubernetes is an open source platform used for deployment and management of containers. So let's get started. Now, the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates. And then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command, because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt get install curl. So you have to select Y, and this will take a few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key, and then we have to add it using sudo apt key add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now moving forward, now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl, and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that, sudo swap off -a. Now let's go ahead with the initialization, sudo cube adm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster we have to use these three commands. Let's just copy paste it. Okay, that's done. So moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment. environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers, and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong cluster management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. environment. The actual control of data within a cluster it's very flexible within Kubernetes. You can have local storage such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have